So thank you for joining, everyone. I'm Lizzie. I work at Balena, and I'm really excited to introduce you to Marc, one of our developer advocates at Balena, and Xosé, Pérez, who is one of our ambassadors, but also works at RAP Wireless, and they're going to talk to you about LoRaWAN apps on balenaHub today. Yeah, thanks for joining. It's our second balenaHub meetup, so this is really exciting. So yeah, enjoy. Take it away, guys.
All right, so I'm going to share my screen, but Jose, you just do something like this and I will just
like magic.
Off to the next slide. Exactly. So yeah, welcome everyone to the second meetup. We are super excited actually. And when we were deciding the topic of the second meetup for balenaHub, we were saying like, yeah, so we have tons of LoRaWAN applications on balenaHub. So yeah, let's start showing what are all the balenaHub applications about LoRaWAN, and maybe let's educate as well, no, people from the community about what it's LoRaWAN, and so on. So yeah, I thought it was a great opportunity to meet up again with Xosé, that we met in person 2 weeks ago, actually, no, for 2 minutes maybe. But yeah, at least do it again virtually. So I think we have an introduction slide. I don't know if you want to do an introduction about yourself, Xosé.
Recording in progress.
Yeah, well, nothing else than what it says here. I'm actually a freelancer. I work for different partners and companies, but most of the time for RAP Wireless as product owner, which means that I kind of design what I like, what I'd like to have, what I'd like to play with, which is a great job. And also ambassador at Balena since last week, 2 weeks. So really, it's really great to be here now and explaining about everything LoRaWAN.
Awesome. So I'm Marc Pous, I'm developer advocate at Balena, and yeah, and I love LP1, the low power weight area networks, no, including LoRaWAN and many others. And yeah, and feel free to meet me on the forums if you are not from Balena. So let's move. Yeah, so maybe let's explain what is LoRa and LoRaWAN, Jose.
Yeah, so first thing, LoRa is it's a modulation, it's radio modulation, just like FM, AM, or some of these others we all know about, but it's especially well suited for low power and wide area networks because it really reaches very long. It has a ratio of noise to signal which is very low, which allows it to really go deep into places and far away. Actually, the record in LoRa communication is that maybe about 800 kilometers long. A link from 800 kilometers long with as low as 25 milliwatts, which is something really ridiculous. So it's a very very good communication technique for long range communications. And on top of that, we have LoRaWAN, which is a MAC protocol, a media access, which basically it says, okay, now that we have a radio communication between two devices, I want to create a network with this LoRa thing. And the way to create a network is that every device has to have a way to identify itself, to encrypt the information, and to communicate with a server, so the server knows that he is an allowed device to connect to him. And that's more or less what LoRaWAN does. All these communication stuff between devices and network through the gateways, which is something that we will talk today.
So it's a star topology, right?
Yeah, it's a star topology. Different devices talking LoRa can communicate to a LoRaWAN network server through gateways, and each gateway can give access like this. Yeah, right. So we will have like millions of devices on the deployed on the field, and all these devices will communicate with gateways in a star topology. So each gateway will provide coverage to according to LoRaWAN, between 1,000 and 10,000 devices each, depending on how far away from the gateways they are. Okay, if they are closer, the capacity of the network of the gateway is larger. So the gateway will be able to provide coverage to about 10,000 devices. If they are far away from the gateways, then the capacity is lower. Then all these gateways, really what they do is just forward these LoRa messages via IP, so via an internet connection, to a LoRaWAN network server. That's the piece of the code that actually manages all the messages, decrypts everything, deduplicates messages, and actually sends the information to the final client applications. So this is more or less what we have. We have devices, we have gateways, we have a LoRaWAN network server, and we have client applications. The devices usually are like low power devices, like I have here like a rack, WizBlock, or any other LoRaWAN device, LoRaWAN compatible device. Gateways, we will have different types of, maybe we can, I think we can go to next slide.
Yeah, sure.
Mark.
Sorry, yeah.
Yeah, so I was saying the gateway is just these special device that just forwards messages from a LoRa communication between the LoRa device and the gateway itself to a LoRaWAN network server. And to send this information to the LoRaWAN network server, it uses something that we call a packet forwarder. So it forwards packets, messages to the LoRaWAN network server and receives the messages from the LoRaWAN network server and sends them back to the devices. Okay, and we will see that there are different kinds of these packet forwarders, different specifications, and actually we can use several of them, not on the same gateway. The gateway will only talk one of these protocols with one of these LoRaWAN network servers, but we can deploy different of these protocols in a given gateway. Okay, next slide. So a gateway, what is a gateway? Actually, I have here a couple of them, so I can show you this or this one. Maybe this one is better tonight. So in a gateway, we will have, of course, so we will have a sensor like the one I was showing before. This is just environmental sensor. It sends temperature, humidity, CO2, and pressure. Okay, so we have the gateway with an antenna, very important. This is a developer gateway, so it's a small antenna. We can have bigger ones. And the antenna is connected to something that we call a concentrator. A concentrator is kind of a radio receiver, but that it can actually listen to different channels at the same time. So instead of focusing on just one channel and one spreading factor, which is something in LoRa that you maybe don't need to know about right now, or maybe you already know, but it's just a characteristic of the communication. If you are talking one device to another device, they have to be on the same channel and same spreading factor. If you are talking a device to a gateway, the gateway is actually listening on different channels and different spreading factors at the same time. So it can provide coverage to multiple devices talking in different channels on the same band and using different spreading factors. That's the key thing for a concentrator. And the concentrator, which is a hardware part, usually in a mini PCIe form factor like this one, this part here. The host, which is the machine underlying, I have a Raspberry Pi connected to it right now. The host has a service running, which is the packet forwarder. And the packet forwarder listens to the messages that come from the concentrator and forwards them to a LoRaWAN network server in a specific protocol. Okay. So
yeah, in this case, this is the schematics of the basic station that it's using the web sockets here, right?
Yeah.
But we are going to show others that don't use web sockets.
Yeah, right. So the packet forwarder, like I said, it's a software. So it's a service running on the host, on the Raspberry Pi, on your machine, that listens to radio packages coming from the concentrator receives and sends them to a LoRaWAN network server. That's what we call an uplink. It's easy to remember. The uplink goes up to the cloud. Okay. And the way to send that is via IP. So it could be TCP or it could be UDP or any other protocol. Usually the two most famous packet forwarders are UDP packet forwarder that uses UDP, as the name says, and basic station, which uses WebSocket Secure, which is TCP. So either way, it's an IP connection, so to the internet or to a local server, whatever. And the other way around as well. So the LoRaWAN network server can send downlinks, so messages from the cloud to the devices. The gateway will then receive that downlink via the same IP connection, and then it will forward it via LoRa to the final device. Okay, so there are some differences in small things like GPS synchronicity and all this kind of stuff that it's not main to the, well, sometimes it is, depends on the kind of gateway, but basically the gateway, what it is, it's dumb. It's a dumb thing that just forwards messages up and down. Okay.
Yeah, we are going to simplify as well the type of gateways, right? A, B, or C, no? The class, sorry, not the type.
Yeah, those are the types, the class of devices, not gateways. But you're right. So we have different kind of devices, A, B, and C. Just to make it quick, an A-class device is a device that just sends a message, and after sending a message, there is a window, time window where it can receive a response. And otherwise, it's not listening to the network. So it's only able to receive responses after sending a message. This is the most usual type of devices, and they are usually sleeping, like in low power modes, to save battery, and only wake up to read from the sensor and send a message and wait for an answer if he needs an answer. Otherwise, he will go to sleep right away. B, going to C instead of B. C kind of devices are devices that are always in RX mode, always listening. These are usually devices that are connected to mains, or to power, to not battery powered devices, not autonomous. And the most typical use is this kind of devices, like power monitors that are already powered by the grid. So you can have a LoRaWAN device listening all the time to possible events like switch on, switch off. And at the same time, they send, in this case, power measurements every minute, every 10 seconds, whatever you want. And then in the middle, there are B devices, which are devices that do not require to send a message before receiving a response. And that requires that there's some negotiation between the device and the network. So the device will tell it, okay, I'm going to wake up every 30 seconds and listen to something. If you have something to say me, then that's the moment you have to send. So these are beacons, like moments that the device wakes up to listen. No need to send before listening. And for these kind of devices to work, they have to have a very good synchronization with the network, which means that usually they have like a GPS with some kind of PPS input. And the same for the gateway. They have to have a gateway that's synchronized via GPS usually.
So the gateways that we are going to show in some minutes, Jose, they are A and C compatible with A and C devices. Sorry.
Yeah, they are. All of them, they are compatible with A and C, and most of them with B as well. So it only depends on the
LoRa network server needs to provide this synchronization. Okay,
right. But most devices you can find are either A or AC, and very few of them actually. I have never tested the B type, a B class device, so they are really rare.
A question.
Yeah.
About the gateways, the RF part, the RF module of the gateways is different hardware compared with the LoRa device, or it's the same configured with another way?
No, the hardware is different. A gateway, to be a proper gateway, it has to be listening at least on 3 channels. That's for Europe. I'm not sure about other regions, but for Europe, it has to listen to at least 3 channels. And that means that, well, you could, theoretically, you could create a gateway with 3 different transceivers listening on different channels, but then you will not be able to use different spreading factors. And then, so in the end, what you need to create a gateway is a concentrator, which is this kind of, this piece, this mini PCIe, you see, like this one. which actually is listening to, for a Europe compatible concentrator, it listens to 8 different channels and 6 different spreading factors, so 48 different combinations in total. You would need 48 different transceivers, each of them configured with a different channel and different spreading factor to mimic that same behavior with just a transceiver. So it's a completely different hardware.
Thanks.
We have a comment on the chat I didn't realize from Salman, but I think he was referring to the E-type class, right?
GPS for PPS timing, right? So the GPS output, all the GPSs, they have like PPS output, which is synchronized with a second, and that's what the gateways use to synchronize with gateways and devices used to synchronize with the network.
Okay, next slide, it's about, okay, what's the best gateway that we can do, no? If we want to set up a gateway.
One thing, yeah, so one thing that we have to keep in mind is that the best gateway really depends on your use case and what you want to do with LoRa or with LoRaWAN. So there are different kind of gateways. There are commercial gateways on the market, like indoors, like I have here a rack edge light 2, which is an indoor gateway, really cool, or outdoor gateways like this one.
This one, it's not sorry, the first one, it's not a single board computer, right? Can you tell more?
No, this is based on a MediaTek chip, and it's not meant to be customized. So it just has a custom firmware. This is a rack wireless gateway. It has a custom firmware called WizGate OS. And it supports everything you need to connect this gateway to pretty much every LoRaWAN network server out there. And the same thing for outdoors. They are normally more ruggedized, ready to be deployed.
Nice enclosure, huh?
Yeah, nice enclosure is really good for this one. But then we also have gateways that we can work with, or we can customize, like based on a Raspberry Pi, like the ones we are showing now. The good thing about this, or the curious thing about this, is that in the end, the concentrators, they are all the same. They have 4 kind of chips that Semtech sells as a concentrator: SX13, 01, 2, 3, and 8. And all of them have one of these chips inside. And most of them actually have the same module, the same mini PCIe module, for instance. All the rack wireless, we are selling different concentrators with different of these chips inside. But it doesn't matter if you are using a commercial indoors gateway, a commercial outdoors gateway, or a Raspberry Pi based, it's the same concentrator inside. So it will really depend on some other factors, like the convenience or your solution. So sometimes you already have something on the table and you want to use it to create a gateway. Or sometimes you don't want to bother about doing a gateway yourself, then you buy a commercial one, right? Then you have to take, you have to think about the maintenance and the remote management of the gateway. Most of the commercial gateways already offer some kind of solution by the manufacturer itself, where you can actually remote manage the gateway. Or if you're using a do-it-yourself one, then you have the good old SSH thing, or you have Balena, which is great for remote management, right? Then you have to think about the hardware. Chips are the same, base designs are the same because they are provided by Semtech. Sometimes the other parts of the gateways are not the same because each manufacturer will have its own procedures. So there might be small differences there, and there are cheaper and most costly gateways because of these differences. But in the end, actually, what it really makes a difference is two factors: the antenna and the location of the gateway. The location of the gateway is key point number 1. And of course, it will depend on your use case. If you want to deploy a gateway for your domotics home automation thing, then you will probably need an indoors gateway that will cover your house. But if you're going to deploy a gateway to manage a fleet of sensors deployed on the field, then you might want to have a gateway deployed on top of the building, not really not really high, but that really covers the the zone where you are going to deploy these devices with no obstacles and with good ground connection, right? So point number one, when you're going to have the gateway deployed, is location. And actually, really, the rest of the things are not as important as location, okay?
Actually, Alan was showing an antenna. I mean, what you were speaking. What's that, Alan?
Yeah,
I cannot see him.
Can you hear me now?
Yeah, I can hear you.
Oh, good. Yeah, I got this recently. I have a lot of LoRa equipment, but just haven't had a chance to put it together. But this is a, let's see, what does it say here? Yeah,
Like saver.
But what you were mentioning, ground connection, can you explain a little bit, like if you're talking about an antenna, what do you mean? Because I have the antenna, but I'm not sure about the ground connection.
So all these antennas are actually monopoles. So if you a little bit about antennas, the best possible realistic antennas are dipole, something like these, but we usually don't have this chance, so we use only a monopole, and a monopole requires a ground connection. So all these metallic parts in the ground, they are connected to the outer side of the connector in the gateway itself, and the gateway usually, like, let me show you this one. They used to have like a special, now I won't be able to find it, this one. I guess it's this one. Special place where you can tie a wire and connect it to ground. I mean to ground like the ground in your house. Okay, the ground in your house. Because this way, what a monopole relies on is that if you have an infinite ground, then the monopole behaves exactly like a dipole. But of course, we don't have infinite grounds. And if the gateway is isolated from the ground will be really small in size. So the performance of the antenna will be subpar. It will not be as good as it should. Yeah. So if you have the antenna connected to the gateway directly or via cable, then connect the gateway to the ground of your house or directly to the ground, like stick a metal something in the ground of your yard. Something like that.
Right. Yeah. That could also act as maybe a lightning arrestor as well, right?
There are specific parts for lightning arrestors. The lightning arrestors you can buy. They are not very expensive, and depending on if there are other objects, other antennas in your location, it might be a good idea. Otherwise, you have some risk of frying the gateway and antenna itself. But yeah,
is this common to happen?
In my experience, so here in Barcelona, we work with and other people that are doing like Wi-Fi peer-to-peer connections. They have a lot of antennas in Catalonia, like 50,000 antennas, and they sometimes have these kind of problems, but once a year, something like that. So it's not really common, but it's something that you might want to have into account, and it will depend on where you're deploying the gateway, the location itself. And of course, if you have a lot of storms where you live. Yeah.
Maybe it's a good idea to place a web video camera in front of this when it's deployed on your house, Alan.
Yeah, thank you for that info. We do get a good amount of lightning around here. So
it might be a good idea to have a lightning arrestor,
yeah.
And it will double as ground, yeah, sure. Okay, so
we have the last slide, actually.
Yeah, so this is about the gateway. So if you remember those four elements we had the devices, we had the gateways, we have the LoRaWAN network server, and we have the final application. The final application is something that you will develop to get that information to some kind of third-party IoT solution in the cloud, or maybe something in-house with Node-RED, whatever you want. The devices will always be yours, usually, because that's what you are actually deploying on the field. The gateways might be yours, might not be. And then we have the LoRaWAN network server. Again, this is a software. It's at the core of every LoRaWAN network. And it's responsible for the connectivity management, monitoring of devices, gateways, applications, connectivity, security, deduplication, all this stuff related to a network of devices. So all the messages that come from the devices and go through the gateway, each gateway will be connected to just one LoRaWAN network server. And that LoRaWAN network server will be what defines the network you're connected to. So if you're connected, you're using the Things network, for instance, which is a LoRaWAN network server, all the gateways on that network, they are connected to the Things network server. If you're using Ilium, if you're using Actility, if you're using Red, if you're using Everynet, whatever, they all have their own LoRaWAN network server, and that's where all the messages go to, and where you have to connect to get that information from your devices. So aside from all these software as a service, LoRaWAN network service that you can find and you can pay for, there is also the option to have your own deployed in-house, like self-hosted, or in your device with Balena. And there are actually two of them, which are maybe the most famous ones, and they are open source. The Things Stack is the software that the Things network runs and the Things Industries runs. And Chip Stack is another one, which is just as good as the Things Stack, no preference between them. But both of them are open source. You can deploy them locally, and you can deploy them with Balena. Well, Marc is trying to deploy the Chip Stack with Balena.
This is on my to-do list since a long time ago.
We will get to this.
Chip Stack on Balena.
But one of the services that we do have in Balena is the Things Stack. So you can actually deploy one of these on your Raspberry Pi or single board computer. So you will have like a gateway with a basic station packet forwarder and another device with the Things Stack, or you can have them both on the same device, the same Raspberry Pi. And that's what, it's not a name that everybody uses, but I usually say like standalone solution, where you have only one device that acts as the gateway and the LoRaWAN network server at the same time. And it might be a good solution for small deployments, like house deployment or a specific project where you are going to have just one gateway that will both receive the messages from your servers and ingest them into the LoRaWAN network server, and then you can connect to it to get the information, or you can even deploy other services in the same device to monitor that information, send notifications, or graph that information. That's something that we already have as well in Balena.
So you have these on balenaHub. Let's try it, no?
Yeah, sure.
So, yeah, first of all, yeah, I think it's time. Yeah, we already talked too much, so it's time to go to balenaHub. And actually, if you go to projects and you search for LoRa, you are going to see most of the Xosé's application and another user from the community, and maybe my old basic station gateway. So I think my idea was now go one by one to all of these applications made by Xosé. So if we go to your profile, maybe we can go one by one commenting, and then we deploy the standalone LoRaWAN gateway.
Okay. So here we actually have three different kind of applications. So the UDP packet forwarder and the 2G4 UDP packet forwarder and the basic station, they are all packet forwarders. You don't want to have more than one of these on your device, so you have to choose between one of these. Okay. Differences. UDP packet forwarder is the old packet forwarder by Semtech, the old definition, the old specification by Semtech. It was not really meant to be something that has to be put in production, but since there was no other solution at the time, then a lot of gateways, most of the commercial gateways out there do support UDP packet forwarder. The problem with UDP packet forwarder is that it's very simple and it doesn't have encryption by itself. It uses UDP, which means it's stateless by definition. So it has some problems that you might want to, but you can use it, but you might want to secure it somehow with a tunnel or this kind of stuff to make it more secure, the communication between the gateway and the LoRaWAN network server. The 2G4 UDP packet forwarder is the same packet forwarder, but specifically for 2.4 gigahertz LoRaWAN modules like this one, LoRaWAN concentrators. So most of the concentrators you will find in the market are meant for the specific region where you live. Like Europe, United States, China, whatever. And all of these are usually supported by UDP packet forwarder. You will have all these options, and you will have to select what frequency you're using or you want to use for your UDP packet forwarder. But for the 2.44 gigahertz, it's different because the concentrator itself is different. It's not based on one of those SX130 whatever that I mentioned before. Instead, it's actually like 3 different transceivers. So the packet forwarder is a different piece of software, and I deployed it as a different application. But in the end, it works just the same. You have to deploy this one if you have a 2.44 gigahertz concentrator, and it will connect to your LoRaWAN network server the same way if the LoRaWAN network server supports it. The reason for 2.4 is that as the 868 or 915 or 434, they are regional, and you should not use a European gateway in the States, for instance. You can actually use 2.44 gigahertz everywhere in the world. It's an open frequency everywhere in the world, so it's something that you can use everywhere. Not only the gateway, of course, but the sensors as well. So it was like an interesting asset for people or for projects that were not located in a specific region. Actually, the first one that I heard of was a ship fleet, like ships that were going all around the world, and they needed to use a frequency that was available everywhere. That's why they invented the 2.4 gigahertz. So these 3 are packet forwarders. You choose one of them.
Is it the same nature or is it something else?
Sorry, can you say it again, because I lost the first. Yeah.
Yours looks like it happened.
Oops.
Oops. No.
Anan, I think it was Anan who was speaking, but we didn't hear you very well.
Maybe
I'm not sure if
typing it in the comments.
Yeah, can you write it down on the chat, please?
Yeah, right. 2.4 is universal, and that's right. Range is limited. It will not be the same as with 868 or 915, of course. So it's like a trade-off between two things. So these 3, yeah. It will still be long range, but not as long range. So maybe it should be not as LoRa. Okay. Anyway, so we have these 3, which are packet forwarders. You will only have one of these deployed on your device, not the 3 of them, not 2 of them. Then we have this.
So, yeah. Sorry. Go ahead if you didn't finish. Sorry.
No, I was going to talk about the things stack now.
No, so no, going to the 2.4. Do you think this is to solve the roaming? I mean, if I have a LoRa device moving, like a GPS moving all around the world, how the roaming is being solved on LoRa? There are like techniques to. So imagine that it goes from Europe to the US and then to India and then to Japan and back to Europe. So what's the idea?
I will differentiate between roaming or peering and having the ability to use a band all around the world. So on one side, 2.4 is to not being limited by band regulations, so you can use it everywhere. But then either you have a network deployed everywhere you're going to go, or you have to have a peering solution between networks. So LoRaWAN has a specification for roaming, but there is also other solutions, like people behind the Things Network, the Things Industries, they have their own roaming solution, which is called the packet broker, which is kind of a software solution on top of different LoRaWAN network servers. If your LoRaWAN network server receives a packet that it's not meant to itself, so it's not a packet from your network, and usually it gets discarded right away, right in the moment that the message integrity code does not match. But if you are connected to the packet broker, then what it does is that message is forwarded upstream to the packet broker, and the packet broker tries to find the network for that message. So it's like with cellular roaming. If you're calling somewhere that is not in the same company you are still able to talk to him, right? So it's the same solution.
Okay, thank you. Oh, we have a comment from Jordan on the chat saying using 2 gigahertz also opens up potential for S-band satellites. Lacuna Space was working on making this possible recently.
Good to know. I know Lacuna because I've been in the things industries conferences last year. Well, not last year, but before the lockdown,
before the pandemic, before COVID.
But I'm not aware of everything they're doing, so it's good to know. Thank you.
Yeah, so on the IoT Solutions World Congress in Barcelona a couple of weeks ago, yeah, there were a couple of satellite companies, yeah, using LoRa, but I didn't realize if they were using 2 gigahertz or what was the frequency that they were using, honestly.
LoRa and satellites is like a hype right now, as I see, and it will be interesting
mini
to
satellites,
see
right?
Mini satellites, yeah. And it will be interesting to satellites. We'll be interested to know to see what's coming up from them.
Well, that's interesting. Yeah, I never tried it. I'm looking forward to. I don't know if you have any Lacuna Space in your house. But okay, no, okay. So maybe it's a toy to have soon.
Maybe.
Okay, so yeah, sorry that I interrupt you, but I think it's time for the basic station.
Yeah, so we have this service, which is a packet forwarder deployed on our machine, and we can also have the thing stack. The thing stack is a LoRaWAN network service, so you can deploy it on the rack, on the Raspberry Pi or your single board computer using Balena as well. And the good thing about it is that if you're used to the Things network, for instance, it's the very same software, so you will know how to use it right away. And also that since if you deploy them in the same machine, basic station, for instance, and the Things stack, then you will share some configuration between them, and using Balena will make it easier to deploy both on the same device, and that's something we can test now. And finally, the standalone LoRaWAN gateway, like I said before, standalone concept, like everything you need to have inside the same device. So standalone LoRaWAN gateway is actually a Docker compose file that you can deploy using Balena. And it has like basic station, it has the thing stack, but it also has Node-RED, InfluxDB, Grafana, and Wi-Fi Connect. And I think that's it. Yeah.
We have the Balena blog Wi-Fi Connect for Raspberry Pi, cool. We have Node-RED, amazing, from the Balena blogs.
So you pretty much have everything you need to have like a proof of concept deployment, something you can play with everything in it. So you will have the gateway part, you will have the LoRaWAN network server part, and you will have the final application part in the same device.
So that means actually that in one Raspberry Pi, if you have a LoRa concentrator on it, you can handle your own private network, right?
Completely, yeah. Everything in the same place.
You don't need to trust like a third-party cloud service that will route your messages.
No, everything's self-hosted. Yeah.
So you can have the Alan's antenna and then cover like some miles around your place and have. What do you think it's a limit of some 1,000 devices? No, you mentioned the.
Yeah, of course it will depend also on the host you're deploying that to. I would recommend if you're going to use all this stuff and you're going to use more than a few devices, then I will strongly recommend you to have a powerful, like minimum Raspberry Pi 4 with 4 or 8 gigabytes of RAM, and that will probably work. I have not tested it with more than a few devices, but that should probably work for some hundreds of them.
I shared the link of this balenaHub, and actually I have it here running actually on a Raspberry Pi 4 with a rack 2287. I don't want to move it a lot, but yeah, the cable it's not. But this is my Raspberry Pi with the.
You have to connect the antenna.
Yeah, I know, but yeah,
important.
Yeah, whatever. I will try to do a test with maybe as well you can explain, if anyone wants to get introduced into the LoRa world, what is the cheapest or the easiest way to make a device, no? Because I know, for example, Andrew wants to start sensing part of his farm, or like vegetables growing, etc. So what should he buy to have like I don't know, a soil moisture sensor with LoRa or things like that? Can you recommend something
with
we get into?
Yeah, like with the gateways, there are two different approaches here. The first one is go to commercial solutions. There are a lot of them. Mind that agriculture is one of the most interesting sectors or verticals for LoRaWAN because of its specific characteristics, like long range. You can cover a long land with just one gateway. But then there's the other option, which is do-it-yourself solutions. And by do-it-yourself right now, it doesn't mean that it's going to be something like not working all the time or something you cannot trust on. There are really good solutions in the market from different manufacturers. I'm from RAC, so I would recommend WizBlock, which is a really great solution for prototyping, but not only prototyping. It really you can have very integrated solutions. Here we have this is a sensor with LoRaWAN and Bluetooth for configuration, and there is a small environmental sensor here, which is a BME 680, humidity, temperature, pressure, and CO2. But you can have lots of different stuff like this monster here, which I'm playing with a screen as well, or with audio. The good thing about WizBlock is that it's like a Lego solution where you have something very integrated, but with many different options to integrate it with. Yeah.
Okay, so let's try to run this. Actually, let's put the HTTPS. And yeah, if you do HTTPS and the local IP address, well, yeah, I already logged in some minutes ago. So the default login and password, it's admin, and the password is change me, right? It's on the documentation, actually. If
One thing before going forward is that, so this project is meant to be isolated from the internet. So security right now, it's not integrated into it. More than it uses HTTPS with a self-signed certificate, but for instance, Node-RED or Grafana, they are not secured. So right now, it will require some more work if you want to make it available publicly or from the internet, which at the moment I'm not suggesting at all. So it's for self-hosted deployments, local network.
Okay, once we say that, so let's go to register a gateway. No, this is using Basic Station, right? We have Basic Station running as a service.
Yeah.
So the EUI, if I'm not wrong, it's here. So I'm gonna copy this tag.
So the EUI is like the identification of the gateway. So it's like claiming that this gateway is yours. You have to know it, and then you can create the gateway. You can register gateway on your server, and you have to set at least the frequency you're going to use.
Okay, I create the gateway. The ID cannot be registered. Okay. Okay, so we have the Basic Station Balena gateway, and now I'm going to register the API key.
Yeah, because Basic Station uses a secure connection. It will use the certificates that are already on the server on the Raspberry Pi, but it needs an API key with permissions to forward messages to the LoRaWAN network server, and that's what Marc is doing right now. And once you have the key created, you have to go to the Balena cloud and add this as a new variable. So now the Basic Station, well, actually everything will be rebooted, and you will soon see in the console that the gateway starts connecting to it.
Okay,
So if you go out to the console, to the thing stack,
let's go.
and refresh.
Yeah, it's offline, so it's still probably didn't start the service. It says disconnected. So I'm trying this from first time I try this fleet actually. So, fingers crossed. Okay.
Yeah, here it is. Here it is. Yeah.
Connected.
So you have now you have the packet forwarder service, which is basic station, connected to the thing stack service on the same machine.
And actually,
which means that you should start receiving like messages from the sensors.
Yeah, I don't know if I'm not sure what is the last program here, but it should send some LoRa messages, right?
Yeah, and at the gateway level, at least you should see the traffic.
Exactly.
Even though the gateway or the LoRaWAN network server might not recognize that traffic as belonging to his network, you should see it.
I don't know. Let me try to find something else, an Arduino or something. Not sure if I have it here. No. Oh, we're gonna miss to see the traffic going live. I just cleaned my desktop, so I don't know what are my LoRa things, honestly.
Yeah, I'm trying to do it myself too.
Okay.
Because I have this deployed. Maybe I can. Yeah. Well, I'm doing exactly what you've been doing now. Registry, creating the gateway.
A sec. Okay, I found. Sorry, this is a competitor from WizBlocks. It's a HealthTech board. Sorry for that. Let me see. Let me try. At least if we see some traffic. Let's see. Okay. Fingers crossed. We are not lucky.
No.
No. Well, let me know if you can share a screen and show something more.
Hold on just a second. I'm registering the gateway.
It's interesting to see. Yeah, so it receives something.
Mark, could you refresh the web page of the basic station, because it only showed one time the gateway status, and it should be coming around every kind of like 30 seconds or something like that normally. I
not
guess.
For basic station, not for basic station.
Oh, okay.
Yeah,
no.
Basic station is WebSocket, so it might.
So there is no ping like in UDP packet forwarder every 30 seconds.
Let me try to. So with the distance that I have, I don't need the antenna, right, for the concentrator, or maybe that's a problem. That might work.
I will strongly recommend to always connect an antenna to a radio device, whatever the device is.
Have an antenna. Wow, it's blue. Okay, have an antenna. 2 antennas. But actually the logs, this is getting too nitty, but yeah, it looks like, yeah, we received something. It says timestamp, counter correlation, wrong, calling rate. CRC fail. Not sure. Time sync rejected.
Okay, I have the gateway connected now to my instance. Maybe I can share my screen.
Sure. Okay.
This one.
I stop sharing, yeah.
Can you see my screen now?
Yeah.
So I have the very same setup. I have the standalone, the basic station, and the rest of things, the stack working. I create a gateway. I call it test gateway 01, and it's receiving messages. I can test that because, well, these are every 20 seconds. My sensor is sending a message. I have lots of things on the desk, but yeah. This is working fine right now. But what I have to do is, right now at the gateway level, I'm just saying that the device is sending messages, but this device is not registered to my LoRaWAN network server, to the LoRaWAN network server that I deployed on the Raspberry Pi. So first thing I have to do is to really register it to it. So I will create a new device, new application here. I will call it tested2, very original. And I will create a new device. It's a rack wireless WISBlock.
Oops.
Yeah. This one, I'm Europe, and frequency plan is recommended one. And then since I'm not going to flash the device again, I will have to find the keys that I had for it. Wait a second. Oops. Hold on, where it was. Here, okay. So I have the keys here. I have the device UI. No, this is application UI, sorry. Device UI.
I always get lost here.
The application UI is everything zeros. And this is the application key. And this is my WISBlock device number 1. Okay, I'm registering it now. So now it's registered, but I have to join the network. So I will reset the device by pushing the reset button, and we should see the device trying to join the network. Here it is.
Nice.
And if the join was successful, then it will start sending messages here, and we will see it right now here. Okay, so we have the messages, the device now registered in our network. So in the network, in the LoRaWAN network server running in our machine, in our Raspberry Pi. Next thing I'm going to say is to tell him that the device is actually reporting messages in Cayenne LPP, which is a codification standard. So new messages now should be decoded directly. It sends messages every 20 seconds, which means that in 7 seconds we will receive new message, and we should
and you will see the payload, right? The code.
We will see the payload decoded. Right now it's the payload. Here we have it.
This.
So we have the payload here, which is missed it here. Temperature, humidity, pressure, and the analog out is actually the CO2, which to be honest, I'm not sure this is right. So forget about it. Okay, so but these three should be right: temperature, humidity, and pressure. So we are receiving these messages, and we are able to decode them. Next step, since we also have all the application level in this device, we can next go to same IP, which for me it's the 106, and to the Node-RED service, for instance, which is running on 1880. And here we have Node-RED. This is the balena Node-RED image. The password username is balena and password is balena as well. So we have Node-RED running on the same device. Everything is in the same device. We actually, not right now. So we should be able to listen to the messages from the LoRaWAN network server on Node-RED. To do that, the most common way to do it is using MQTT. MQTT is a message protocol, specially meant for sensors data, which Node-RED knows about, because actually it's by the same people that created MQTT. And on the LoRaWAN network server, there is an integration. We can publish all the information that we are receiving from the devices as MQTT messages. So first thing I'm going to do is to copy a flow. A flow is like a program, like code in Node-RED. And I can import it here. Okay. And as you can see, there is a node that it doesn't know about, which is influx node. I can install it now. Manage bullet. Install influx. Influx is the database we are going to use. And this node allows us to directly ingest the information that we are receiving via MQTT into the influx database, InfluxDB database. So now it's connected. And next step would be to configure the MQTT connection. So to configure it, we have this stack. If you know a little bit about Docker, this will resolve to the stack service inside Balena.
Yeah, it's the name of the service running.
Yeah,
Balena.
It's this name here. Okay, stack, the same name here. This is the non-secure port, but since it's local, I'm going to use non-secure port. And for the security, we need a username and password. And that's what we are going to create here in the integrations option. So as you can see, the username is test01, which is the name of the application. And the password, we are going to generate it now. We copy it and we paste it here. And now we deploy. And it says connected. And in the debug, we should start seeing the same messages that we were seeing in the LoRaWAN network server, but now here, because we have this debug node here, outputting everything like influx nets. So let's wait for some seconds.
And then just a bit off topic, but as you're using the Balena block, the dashboard, so dashboard is reading automatically from InfluxDB, right? Is that correct?
Yeah, correct. Correct. Oh, sorry, it's not test up. That's why I was not receiving it. It's test01. Sorry.
Nico is mentioning. Okay.
Yeah. Here we have it, the message.
Cool.
With the payload and the measurement, which is the table we want to save it to. This is set by this node here. The payload is the decoded payload that we have in the message, and the measurement is the device ID. That's why it says WISBlock01, because that's the name of the device. And as you can see, we have an error because the database does not exist yet on the influx. So next thing, I'm going to create a database from here. I'm going to connect to influx via terminal from the Balena cloud. So I'm now inside the container of influx, and I'm running the influx CLI, which allows me to get into it. There is no security here, as I was saying before, so I should be able to just log in and create the database. It's a little bit slow. Create database Balena. Done. That was it. All the code that we had to write. So I'm waiting for a new message, and it shouldn't complain now, because Balena database, as we say here, so you can say we are connected to the Balena database here. And we should have a message here.
You don't
no
need
complaints.
Any login and password? No,
no, it's unsecured completely.
Okay.
So something to improve for sure. Okay. Yeah. So we have it. The message, we have gone through Node-RED, and Node-RED is ingesting the message into influx. The last step would be to use Grafana, which is the other service that we have here. Deploy it. Again, no security. mind it, please. So I'm going to sign in with the default. This is just admin when it starts. I'm not going to change the password now. This is just a demo. And by default, in the data source already comes an InfluxDB connection. That's what Mark was saying before. We already have this ready, connected to the Balena database, and we tested. It's okay, so it's able to connect to the InfluxDB Balena. And now we're going to create a dashboard, simple one, new panel, using the default connection, connecting to the WizBlock01, which is the table that we are creating. And I'm going to plot the temperature. No means, no, nothing. And as you can see, I can say it here. I'm gonna say temperature. And apply. And not 6 hours, but last 15 minutes. So we have this temperature that's being registered, which is kind of stable right now, 25.8 Celsius. It's pretty hot here.
Yeah.
So, and we could do the same with the other variables that we are ingesting automatically. We can use this to use the barometric pressure or the relative humidity, which we see some changes, not very much, but the same thing. Humidity, and humidity, since it's water, it's blue. Everybody knows that. So we have, and we could create a dashboard like that. And we could even create a dashboard with, right now, as you can see, the ingest part is kind of agnostic to the devices because it uses the device ID as a table. So we could even create a dashboard that we could choose what device we want to see, and it will plot only the data from that device. Yeah, and everything is in the same machine. Everything is running on the Raspberry Pi.
It's super cool, Jose.
The gateway packet forwarder, the LoRaWAN network server, Node-RED, Influx, and Grafana.
This is amazing.
And CPU is pretty good, and temperature as well.
What do you have here?
So,
Pi 4? Okay.
It's a Pi 4 with 2 GB of RAM. It's actually one of the developer gateways that we are using at RAC. So it comes in a nice aluminum case, and it's a RAC 7248.
Okay.
But
that
in
means
the
that you need Ethernet
here
cable.
Inside we have the same thing as here. So
okay.
And with the option to connect the GPS as well, which is good.
All right, I think that was amazing. I actually missed that live demos. Questions? Yeah, Paul, we are gonna share the recording. We are gonna upload that on YouTube. And no worries, we are gonna share the recording with everyone. Questions, or I don't know if you have experience on. I know Nico is here, and he has been fighting with new LoRa concentrators as well for a long time. Or Andrew, I'm not sure if we convince you to deploy your own private LoRaWAN network.
Nico was sharing also the TinyJS project.
Indeed,
thank you very much. That's a project by a couple of friends of mine from Madrid. So it's really nice. And talking about LoRa and satellites.
It's an absolute blast. It's just such a cool project.
Yeah.
I was jumping on that bandwagon with FossaSat-1 when it launched back in 2019. I was unlucky, couldn't receive anything, but with my tiny antenna, that was actually not really surprising.
Yeah.
But it was a cool group, and it's nice to see them just going strong. And I think it's an absolutely cool demo of the technology and the possibilities you got there. And I think what's most surprising is this offline running solution, basically, where you're completely private and you're not dependent upon something. As someone who's regularly losing WAN connection and having such a setup running myself here, it's such a cool thing to just like be able to offline, still have your sensors, still work your smart home and everything, and not be reliant on someone keeping the lights on or your connection. And then you're just like, oh, I cannot control my house anymore because internet is offline and stuff like that. So that's from a privacy perspective is so cool. And you guys from RAC giving such nice hardware to us developers to play around with. So impressive stuff, really. Liking
Thank
it.
you. Yeah, and I agree completely. Sometimes it's really important to have a self-hosted solution you can trust on at all times. Completely agree. Actually, when I started in IoT, it was because I really liked all those. I don't know if you remember the SON-off solutions with plugs and power meters, and they will all connect to a Chinese server. I mean, nothing wrong with that. But of course, if the server goes down or if your connection goes down, then you cannot turn on the lights or off or know what it's the consumption of your fridge. So it was I started by creating a firmware. You can use MQTT from the devices and connect to whatever you want, not their server only. So yeah, completely agree with you and understand it.
We have a question from Salman. Actually, if you want to ask it away, feel free, Salman. But yeah, he's asking on the chat if is the TTN deployed in V3? Oh, yeah.
Well, I guess this means TTN. Yeah, TTN. Actually, V3, what we call V3, it's the thing stack. So the same software. Although this is a community edition, so the commercial one has some features that the community edition lacks of. But it's the same software, and it runs on software as a service. You can hire, you can have your own instance there. And TTN is actually just another tenant of that solution. So TTN is if you contact the Things Industries to have your own solution on their platform, you will be neighbors with TTN because it's another tenant on the same solution. Yeah.
Yeah, I think this is the 3.1. What version are we running? 1 sec. 3.1.9.
So yeah, the things that GitHub shows it. I gotta go to.
No, but the one, yeah, it's not the 3.19.1 we are running.
I think the latest one was deployed on yesterday, and it's the next one. So if this is 3.19, what is the number? Yeah, I think that the new one is the 3.19.2.
Okay,
I'm not wrong. This is the latest one, the one that's deployed on the Things Network and the Things Cloud.
Nice.
I have to update it.
No worries, Salman.
By the way, you can build. I mean, as you know, you can build your own image, even for Docker or for Balena or whatever. And there is a variable there. You can specify the version you want to deploy. It's just a matter of changing it.
All right, Andrew. Andrew says that, yeah, he really liked the presentation and looking forward on hacking on this. Yeah, looking forward to get your feedback. More questions or comments by microphone or by chat, please.
I have a question about this box that I've had lying around for a while. I was wondering, is this is a 2245? Is this still something that could be used for the examples that you were showing?
Yeah, sure. Yes.
Yeah.
This has
not outdated.
No, not at all.
Okay.
This has an SX1301 inside, which is one of the supported concentrators.
Actually, maybe you can share the device variables, what he needs to change just to make it.
Yeah, so basically, as you say, this only impacts the basic station, which needs to know what concentrator he's talking to, like the hardware abstraction layer he has to use. So you have to go here. As you can see in the model, I have the name. So here you can use either the name from the brand, like RAC 7248, the one that I'm using, or you can use the name of the concentrator. So for your case, you can just do this for 5, and it should work. or you can use the chip that the concentrator has inside, which will be like this. Either of these will work. Either one of these will work. So it's like, and it's not only for rack. So we do not only support rack concentrators. If you have, like, I think Mark has one of these, or it should work the same, right? Right, Seed Studio. So if you said if you said that the model is a WM1302, it will work with this one as well.
I also have one of these. Is it possible to use that as well?
Most probably. The main problem here is to know that I guess this is an XX1301 as well, because it looks old.
Yeah, it's old.
It's a USB one.
And is it USB or is it SPI?
I think the USB is for power. I think it's using
only for power.
Hat. So
yeah.
I think the hat, so it's probably SPI. But that kind of brings me to my other question. Could I just use one of these and have two different forwarders on it, so it's used for two different services? Like
you can, with the basic station, yeah, you can have two different, but then you have to tell it what SPI to use, what SPI bus to use, or what USB port to use. If you then, for these more advanced options, then I suggest you to go to the basic station repo, and then here you have a list of all the variables that you can play with, and then as you can see, you can SPI your USB, the design, which means like these are the different designs available. And so if you are going to use two SPI devices, then you will have to wire the CE line to one or the other.
What if I just used just one device though? I didn't even use this old one, but could you actually forward the packets to two different services from one device?
Oh, you mean forwarding to two different services? I was understanding wrong.
Yeah, if I was using
you could. It's not recommended because what defines a network is the LoRaWAN network server. So the gateways belong to a network and they connect to just one of them.
Okay.
To just one LoRaWAN network server. That said, you can do it, but not with basic station. You will have to use UDP packet forwarder. And then, yeah.
Sorry, I was just going to say then in that case, if I did it the recommended way, is having two separate devices running next to each other, would they interfere with each other at all? Or is it totally acceptable to just have these two running separately with their own antennas? Do they cause a problem being in vicinity?
There might be some issues if the antennas are separated with multiple of the wavelengths. So you will have to, I will suggest you to test it, like test if the receive power, the RSSI is good on both of them and all the cases. But yeah, that's the solution, to have two of them running in parallel, connected to different LoRaWAN network servers. I was going to say that there are solutions to do it with UDP packet forwarder. That you can there is even a solution called poly packet forwarder, where you can define two different or more than two LoRaWAN network servers to connect to. The UDP packet forwarder and Balena does not support that, but then there is something called ChirpStack Multiplex by ChirpStack project, one of the projects that I was talking about, and that's what it does. It really accepts an end-to-end relation between gateways and LoRaWAN network servers. So you can deploy that service somewhere, maybe on the same machine, connect all the gateways to that server, and then that service to all the LoRaWAN network servers you want to go the messages to.
And then if you want to see that really dirty method, you could look into our project Show and Tell SX3103 session, because that's something I did so that I can basically chip in my stuff in my own private, also at the local running Think stack, so that everyone gets a slice of the dice.
Yeah.
So, but it's, as he says, it's there. Obviously, these things are also transmitting something like some control messages there, and if you have two controllers at the same time on the same hardware, it works. I actually have to say it works, but if I would have a lot of senders here, not all my only stuff here, because no one is not really using LoRa at my kind of the city for I don't know reasons, I think that would be a little bit more problematic. So For hacking, it's nice.
Yeah, yeah.
Well, I may keep it simple. It seems like every project I have has exceptions and rules, so I may just go the normal route here, so I don't have another project with massive hacking on it.
Alan, I think it's a good idea to really get started with something as nice as a box as you got there, because I started hacking everything together, and it went as good as it could have done if I were going. So maybe you should start it easy, and then you can get
Sounds good.
everything else.
Yep. Thank you.
Cool. More questions, or we will wrap up. It's late.
Yeah.
Thank you, Xosé, for your time, by the way.
Welcome. It was fun. And everything worked this time.
Yeah, except on mine, I think Wood just solved everything. But yeah, sometimes.
I say that because Mark and I, we have a collection of demos that went wrong or did not work.
Well, it didn't go to the desired path, right? Or the desired
no
place. But yeah, it was fun.
Yeah.
All right. If there are no more questions, thank you for your time. Actually, we have, I don't know, Lizzie, if you can, let me share again the slides.
Yeah, I think we're just letting you all know that we have already booked in the date for the next balenaHub meetup. It's going to be home automation related, with a few different home automation projects on the hub. So that will be the 30th of June, 6 p.m. UTC, and I've just shared that link in the chat as well. So if you are interested, you can go sign up. And hopefully we'll see you all next month. Thanks for coming, everyone. It's nice to see everyone here.
Yeah, thanks. Thank you. Have a good day. Have a good week. I'm looking forward to see your feedback on LoRaWAN.